Alright gang, let's deal with Chapter 7, Implementing Virtualization with Hyper-V. Now we've already talked about this in Chapter 6, but now we're going to take it to the next level. We're going to work with virtual hard disks, configure virtual networks, configure nested virtualization, and we can implement Linux and FreeBSD virtual machines. Now, when it comes to virtual hard disks, they can be one of three types: a fixed size, dynamically expanding, and differencing. Now the first two we've talked about quite a few times already in the last couple of chapters. Now differencing uses a parent-child relationship where the parent is dynamically expanding or fixed disk, and the child is a differencing disk. Right. Virtual disks can be created when a VM is created or with a new virtual hard disk wizard. Now you'll need to choose the format, whether it's going to be VHD, VHDX, or a VHD set. And VHDX can support disks up to 64 terabytes. And we've talked about those first two previously. But a VHD set is a shared virtual hard disk used with VM cluster configurations when multiple VMs have access to the same virtual hard disk for fault tolerance and load balancing applications. You'll also need to choose the disk type and specify a name for the virtual disk file and the location on the host where it's going to be stored. So here's our interface to choose a disk format on the new virtual hard disk wizard. Now this will be accessed on the right pane of our Hyper-V manager. It's up at the very top, and we click New, then we click Virtual Hard Disk, and then we've got this wizard will come up. You'll choose your format, and then we choose the disk type. Now, I don't choose fixed that often. Predominantly, I choose dynamically expanding. It keeps my virtual machine smaller as I go. Okay, you configure the disk, the size that it's going to be, and then you point to wherever it's going to be. Okay, so virtual disks can be created when a VM is created or with the new virtual disk wizard. We talked about that. Now there's the things that we can do with it. We can compact it, convert it, expand it, merge it, or reconnect it if it, for whatever reason, has been disconnected from the virtual machine. We've got pass-through disk. It's a physical disk attached to the host that's placed offline so that it can be used by a VM instead of or in addition to a virtual disk. Now, a pass-through disk has modest performance advantages over virtual disk, but it lacks the flexibility of virtual disks. An advantage of pass-through disks over virtual hard disks is that virtual hard disks are limited to 2 terabytes. Now, VHDX, we can get larger. Okay, so here we go with our physical hard disk, what we point to. Now we've got QoS, or Storage Quality of Service. It enables administrators to specify minimum and maximum performance values for virtual hard disks. Now the maximum specified value limits a VM's access to a virtual hard disk to prevent it from consuming too many storage resources. It can affect other VM's access to that storage. Storage QoS can be set on IDE and SCSI virtual hard disks. So here we go. Here's our interface with it. Now Hyper-V is used, when we're talking about storage QoS, Hyper-V is used in a scale-out file server or a cluster shared volume. Okay, there's two types of policies that exist in storage QoS. Aggregated policies, and that applies to the minimum and maximum IOPS. IOPS values to a set of virtual disks working as a whole. And we've also got dedicated policies as well. We've got external virtual switches. Now, an external virtual switch, it binds a virtual switch to one of the host's physical network adapters. It allows virtual machines to access a LAN connected to the host. Only one external switch can be created per physical network adapter. You use an external virtual switch when external computers must have direct access to the VM, or when the VM must have access to the external network resources. Having more than one physical NIC installed on the host computer is recommended. If you're using external virtual switches, you're probably going to want to have more than one NIC. You can dedicate one of the NICs to the host machine and one to the external virtual switch. So here we go, is a graphic of that. We've got internal virtual switches, and they allow virtual machines and the host computer to communicate with one another, but it doesn't give the VMs access to the physical network. They can talk as if the host machine is on their own network, but they can't get out. Okay, so here's the example of that. Now we've got a private virtual switch. It's similar to an internal switch, except that virtual machines connected to the private virtual switch cannot communicate to the host computer. So that's the difference. Okay. Creating a private virtual switch doesn't create a network connection on the host computer. Private virtual switch is used when you want to isolate the VMs connected to the network from all outside communication. You might want to use this setup as a domain testing environment or a development network. And we'll do this in some of the exercises that we do. Okay, there we go. Now, what if you want to isolate VMs in their own private network, but you want them to be able to access other private networks or an external network? Now, there's two ways we can do it. We can create an external and a private virtual switch, then configure one virtual machine with two NICs. Or we can create an internal virtual switch and enable routing on the host machine so that it routes between the internal and physical switches. Now here's the configurations for those. Okay, now if we're going to create a virtual switch in Hyper-V Manager, we'll click Virtual Switch Manager. It's in the Actions pane. Then you can edit any existing virtual switches or create a new one. You choose External, Internal, Private, Create. And here we are. Here's the interface. So we can create a new one. There's an existing here. There's the MAC address for our global network. And then we just pick which one we're going to create. So we've picked an external switch. We're creating an external switch. And we see right there that it's an external switch by the name of it. We gave it an IP address in the name so that it's easy to identify. We can put notes in here, like anything else. The more documentation, the better. It's an external switch, Hyper-V network adapter number 3. And we just go right on down the line. All the options that we need to or choose to enable or disable. Now, virtual machine network adapters must have a unique MAC address on the network. Now, that MAC address, now, oddly enough, in some of the other textbooks, they don't call them MAC addresses. They call them physical addresses. Now, I don't know why different individuals or different authors are coming up with different names for them. It's been MAC addresses as long as I can remember. As long as we were networking, it's been MAC addresses. Now, for whatever reason, if you see somebody saying physical address, they're talking about a MAC address on the network. So Hyper-V must assign a MAC address to each network adapter connected to the virtual network. That's assigned dynamically to the adapter from the pool. pool consists of 256 addresses by default, but can be changed. Okay, so there it is, defining whatever the MAC address range is going to be, your max, your min. So a virtual NIC is created when you create a VM, and you have the option during VM creation to attach it to a virtual switch. You can also add NICs after the fact. So here we are, we got the option to go through and add a NIC. And with add hardware, what is it that we want to add? We come down here, select network adapter, and then we'll come up here, next window, what switch do we want to connect to, and the bandwidth that we're going to use. Right. Aside from connecting VM's network adapter to a virtual switch, you might need to perform other configuration tasks related to a VM's network connections. We've got things that we'll talk about here in a little bit: hardware acceleration, advanced VNIC features, NIC teaming, fiber channel adapters. So we'll talk about VNIC hardware acceleration. Now there's 3 hardware acceleration features for VNICs: virtual machine queue, IPsec task offloading, and single root I/O virtualization. Now the advanced features dialog box, we can configure any of these: a MAC address, enable a MAC address spoofing, DHCP guard, router guard, protected network port mirroring, and device naming. And here we are, we can see the checkboxes one by one. So we can do NIC teaming if we want. And in NIC teaming, here's our interface. Oh, let me back up. All right, we can do it in PowerShell with these commandlets, or we've got our GUI in Desktop Experience. And then we've got different modes. We've got 3 teaming modes: switch independent, static teaming, and link aggregation control protocol. So there's also load balancing mode, which we've got address hash, Hyper-V port, and dynamic. Come down and we can see enable teaming and enable device naming if we choose. Okay. Set, which is switch embedded teaming, is a new feature that allows up to 8 identical physical adapters on the host system to be configured as a team and mapped to a virtual switch. Set is targeted for enterprise servers with very fast NICs. Set supports remote directory memory access on virtual network adapters. You must enable RDMA on the virtual network adapter created on the host system. So synthetic network adapters are network adapters that use synthetic drivers in Hyper-V and offer much better performance than legacy network adapters. Okay, we've got a fiber channel adapter, allows a VM to access fiber channel storage directly from a VM. So here's our fiber channel adapter creation, and we do that through the SCSI controller. We just step by step fill it out, whatever applies. Okay. So now nested virtualization, we can create a virtual machine using in Hyper-V, and then on that virtual machine we can turn on Hyper-V and start creating virtual machines on our virtual machine. Okay. We can implement Linux and FreeBSD virtual machines. Hyper-V supports Linux and FreeBSD virtual machines with no special configuration if you use emulated device drivers. Now I've done this with Ubuntu and Kali. I can't remember, I think one more. So yeah, Linux will run on without a problem. Some newer Linux kernels include support for integration services. FreeBSD releases beginning with version 10 provide built-in support for integration services. So a virtual hard disk is a file on a host computer with a VHD or VHDX extension. Virtual hard disk can be created when a VM is created, or we can do it afterwards just using the menu over on the right side of Hyper-V manager. Okay. So NIC Teaming allows multiple network interface to work in tandem. Load balancing we've dealt with, and if you're using Gen 1 VMs, you have the option of using synthetic network adapters or legacy network adapters. Gen 2 VMs don't support legacy network adapters, and the synthetic adapters on Gen 2 VMs do support PXE boot. Right. So Hyper-V supports Linux and FreeBSD, as we said, with no special configuration if you use emulated device drivers. Nested virtualization is the ability to run hypervisor inside another hypervisor. So we'll see you in Chapter 8, and I've